All right. Hi, everyone. Thank you for having me today. I mean, I apologize for the lateness, but hopefully it will be a nice lecture today, especially since it will be recorded with my sound. Otherwise, I apologize. But thank you. It's truly an honor to be here today because I always dream about the moment where I could play being the professor for one time. Even though you can see the slide, I didn't include professor. Makes me cringe a little. I don't think I'm quite ready. But as you know, I've been in this class for a long time already. This is my last semester of 6. So I want to share with you some of the things I like the most about like MEAM 101 and hopefully make some cool things in the process. So with that being said, let's get started. So let's go over to the next slide here. Yeah, so here's a playlist of the things I will be doing today. Let me just minimize this in here for a second. So you got does anybody recognize the Lego guy in there? It's like Emmett. It's gonna be very Lego themed today's lecture. So everybody wanna have that in mind. So yes, I'll tell you a little bit about myself. I was following like Dustin's instructor for the first lecture. Then I want to show you some maps that I was grading. It's a little bit biased because I was grading just my recitation. Then we're going to do some sketching. So we're going to warm up those engines. That's what I call it. Then we're going to do a pen band shenanigan with all of you guys here. Then we'll go many places. We'll speak about the CWA exam. We'll conclude with some summary. So who am I? So this is me. I'm Andy, as you already know. That's a picture I took about 2 weeks ago when I was in the Boeing Museum. I was there in Seattle, and that's the first 787. And that's like what, from like 2007, I think, or 2006. So it's been quite a while. I really recommend going in there. It's a paradise. So yes, I was part of the Viper program here at Penn. So if anybody is interested in Viper, applications are open to transfer now. But I studied mechanical engineering and math, and I minored in EALC. Does anybody know what EALC is? It's the East Asian Languages and Civilization. So I speak Mandarin, and I've been learning that for quite a while already. And now I'm finishing my master's in energy, mechanical engineering, but specialized in energy. Yes, I'm from Argentina, as you can probably guess from my accent, and hopefully I'll be surprising you later, giving you a little bit of a taste of back home. And then some of my, yes, I've been a TA for 6 semesters, and some of my hobbies include, I'm part of the pen band, as you can see, and we like to wear the instruments as hats, as you can see in the slide. I like to play tennis. I don't know whether you guys recognize the guy that is on the left. Does anybody know who he is? Yeah, it is Alcaraz, the #1 of the world today. So I went to see the US Open about like in early September, and I find him training in the court. So I just saw, I told him like, Carlitos, let's take a selfie, and he was looking down. So that's the best picture I got of him. That's like the biggest celebrity, I bet. Then I like biking. This is me going to New York and taking the Staten Island ferry from Staten Island to the city. It's a long ride. These are my kids. Some of you guys are here right now because some of my hobbies is also teaching, as you guys know. And then yes, I like every time I fly. I like airplanes. I know you saw from the 787 picture. I'm still a kid in many ways. So I like going to the cockpit every time I'm taking a flight. I don't know. This is a cool picture in here. So yeah, so let's take a look at some of the months. Maybe some of you guys recognize some of these. I apologize again for making it. Oh, sorry. Let me just. There we go. Making it be a little bit biased in this case because it's my recitation. I thought these were nice examples. And on today, we'll be doing a demo at some point. We'll be doing some of the stuff. We'll be doing a revision of the things that we've covered so far in the semester. But enough with me talking. Now let's warm up quite literally those engines. So I ask you guys to bring a piece of paper right now. So if you want to pull out that piece of paper, let's do that 1 second. And with that piece of paper, what I'm going to ask you to do is to just try and draw the Saturn V. And you have a nice picture here that maybe you can try to, and if you want to put your name in the piece of paper, that would be great. And that way you can give it to me later. And I can give it to those in that way we can prove that we've actually done something today. So I'll give you like a couple of minutes and you don't have to go pay, you can ask around. And just try, you can do it either as a single piece, as you can see there, or like in modulary. I can show you on the next slide specifically what I'm asking you to do, which is if you grab the Saturn V, try and do like an exploded view, and then try and add some dimensions to how big you think the Saturn V would be. And then if you want to answer A, that would be A and B, that would be nice. Just saying like, how would you model this piece? And maybe what are the sorts of commands that you would use? And here's a bunch of commands. But I think I'll put the picture up for a little bit while you guys try and draw some of this stuff. Exciting. We can suppose for today that you guys are NASA engineers. You're designing the rocket in here. You see. Perfect. I'm so happy that the audio is working today. I was hoping I asked a couple of professors to come. Apparently, there's a seminar going on at the same time, which I should also be attending right now. So he told me to send on the Zoom link. Maybe I'll upload this to YouTube. Yes, absolutely. Yes, there's like the specific things. People like again, this is just like nothing to. I'm not definitely not gonna grade you because of how you do this. I just wanna like warm you up, begin to think about the design process for a second. Given the things I can bring. Let me know if you want me to jump between one and the other one. You can make it look pretty. You can add like the NASA, the USA, or maybe you can add some creativity and make it a little more of your own. I always wish that I remember early in May of this year when people are moving out. I saw in like Facebook exchange, right? Like that marketplace, like about 10. One guy was giving away his Lego Saturn V for $5. And I think that post alone had like 30 different comments of people that wanted to take that. So I was a little bit. So that would have been a nice possession to have. I mean, I saw it once in the Lego store. It's a beautiful rock in that one. Super realistically done. Those kids doesn't walk around like I am in an exam room. Maybe like one more minute or two, but don't focus also so much on the actual drawing because we can continue that later. Also think about how would you actually model this. If you look at something, if your think it's quite circular, right? How would you? What are the sorts of Solidworks commands? And if you could just write them down in there, that would be helpful to try and understand how you can model this out of just looking at the picture. wish we had like one of those like devices where you could like scan your paper and you could show it in the projector. That's a little bit more old-fashioned. One of my professors, when I took MEAM 210, which is statics, like he had that. But the guy never got it again. I guess that it's stuck in time. That's right. Very excellent professor. Maybe when you guys are drawing in here, we have show up of hands. Or just like you want to get them out. What are some commands of Solidworks that you will use when designing it? Yes. So, and how would you do, for instance, in here the paper? You can do a lot. Yeah, we'll do a lot. Now, I like that idea. What is another way of doing it? Yeah, you can also record that. Yes. Chamfer or chamfer also that would definitely work. That would be more following what is the name again? Chris, the idea where you maybe make an extrude cylinder and then you chamfer at the end. Yeah. Any other thoughts on how you do it? Right. And maybe you know that's good. But you guys are all describing like the single piece one. Would you guys think that it would it be much harder to make it as an assembly? The assembly together. Yeah, I think that's it. And maybe suppose that I have like this cylinder design as you guys can see here. How would I draw the fin on the side? Yes. You can use a reference page. So that's perfect. Yeah, so just have all of these different things in mind and definitely write them down because that way you can also look at your sheet in a moment because I'll be asking you a bunch of times how to do all of these things. Now that's great. I let you draw this for a little bit longer, but now it's time to do, yeah, so in here, I give you a bunch of commands that I think could be useful for this. Let's say like maybe wrap in the sense that you can use the wrap command to engrave like the USA and a couple of like the letterings in there. Then what I say circular pattern also might be useful in the sense that I can model just one of the fins and then do 3 more out of that and whatnot. But I think it's time for a mission right now because you guys seem a little bit sleepy and I need to wake you up for a moment. So who here has seen the pen band? The great band, right? And if you haven't seen it, you definitely have to see the pen band because we are playing to play every weekend at Franklin Field. And this is a picture from Saturday actually. I was just like going over there and you can see me there in the left. I'm playing a big horn. It's called the euphonium. But now here's the problem. The pen band doesn't like the trumpets. We call them the chops. So the trumpets are loud. The trumpets, they think they are superior to us because they are superior to us. So one of our bandos decided to break one of the trumpets. So the challenge today is we need a team of engineers to design a trumpet. So now in your sheet of paper, can you draw a trumpet? Just it's like there's a study that I know a trumpet is maybe not the thing that you would have in your mind, but there's a study that asked people to draw bicycles. And you have to see the designs that people came up for bikes. They were things, but not bicycles. Folks, so that's what I'm saying. Like this out of scratch, without actually seeing a trumpet, unless you can recognize it from the picture. How does a trumpet look like? To give you a hint, it has 3 valves, right? Yeah, that's very close. Yeah. So I'll give you like maybe a minute or two to design a trumpet. And I was hoping some folks from the pen band would come, but that doesn't matter because I'm here. So I'll be able to entertain you in just a second. But I'll show you in a moment what a real trumpet looks like. We'll be working with that. And now maybe as you draw your trumpet with hopefully whatever design you do, also try and write a couple of commands that you would use to design the trumpet itself. Because surprise, surprise, the demo that we're doing in just 5 minutes will be designing a trumpet. And I hope I'll try and do it. I've never done it before, so I'm excited about that. It should be a fun time. Oh, it's 9. It's like looking like trumpets. I look more like a flute. What do you believe in?
Had 6 years of that.
And you know what did you play the trumpet?
Oh,
That's what it looks like, right? I mean, if you ask me to draw a sax, it would be another sound. But trumpet is easy. Oh, that looks like an English horn. I like it. Same thing, right? Same brass instrument. They can look. Oh, I like it. Very nice. I like it for my stick style. On the starting point. Like that. Very pretty. It's hard to read all the quarters. This is the game. Oh, interesting. All right, it's getting there. Very good. I like that. Anybody here plays the trumpet, by the way? Oh, we're all right. I like it. Very nice. Very nice. Very, all right. So now I guess I'm done looking at trumpet. So maybe let me show you a trumpet of my own. And it's a funny story how I got this trumpet, because turns out a senior design project last year used a trumpet and they were trying to amplify sound. So when I came back to campus summer break, there was like no one on campus, and I saw the trumpet next to the trash bin to give you an idea how much they care about this beautiful trumpet. And I knew who had done this senior design project. So I go to the guy and I tell him, can I keep the trumpet? He goes like, yeah, I don't care about the trumpet. Nobody likes trumpets. I like trumpets. So that being said, let's just pull out this bad boy. This is how a trumpet looks like. And I will be passing it around in just a second. So now this is the moment in which the mechanical engineering class suddenly becomes a music class. This is the moment that if you want to do like an Instagram story, it's like you drag to your friends. This is what happens to your friends. It will be this. Sorry, I need to warm up one day. Oh, you have no idea, like the band is so small. Yeah. Just give me 1 second. I give it for let me just warm it up 1 second. Yeah, so that's my failed attempt of playing the trumpet. It was it doesn't matter because now I promise I will play it today. Don't worry. Just I'm very bad at it. But now the problem is that now we are gonna design a trumpet ourselves. And I'm gonna give you a hint of some ways I will design this trumpet and we'll do it together in a moment. So one way I thought about doing it is by starting with a sweep. Starting with a sweep. So I would look at like all of this part in here, right? And maybe try and trace like a line that goes like that, maybe a circle, and maybe going it all the way around. Then another way to design it is on the front part, making a knot. So maybe chopping this into 3 cross sections and just trying to loft it there. Then another thing that we can do is also another sweep because it has like 2 systems of or just like pipes in here. And then what else can we do? We can do some extrude bosses, right? Just on like these 3 cylinders. And lastly, we can just do a circular pattern on the valve, which is this little guy that you guys can see in here. Now, if I give you this design, what would be the first thing that you would design? Given like this one, if you were to design a trumpet like this one, what would be like of all of the different components, the first part that you would design?
Mouthpiece.
The top piece?
Mouthpiece.
The mouth. Oh yes, we will do an assembly, but suppose you're looking at the body. Yeah. Oh, you're gonna say the mouthpiece. Well, we can start with the mouthpiece, right? The one? The horn. Perfect. Yeah, I think that could work. Any other ideas? With a piston. Yes. I like that. Yes, it comes from a, and I agree. I would also start by designing the first 3 pistons in there, because then everything else is kind of coming away from that. And then I just have in here just a couple more pictures. Yeah, so now I'm asking you if you guys wanna like write it down also in your piece of paper. That way you'll have it as I start doing it in just a second. What commands would you use, but also what do you think out of this design would be the hardest thing to model? Here. And then maybe how many parts would you design, whether you make this as an assembly. Of course, you would make this as an assembly. So I'll let you copy that for a second while I'll try to interrupt by playing. Oh my goodness, this is terrible. I was playing the song at a higher key. I don't play the trumpet. I just have the bow. If I had my other instrument here, that would be much better. Can I take out the slide, or are you guys all done copying in here? Maybe take a picture actually of this slide for a moment. That way you'll have the trumpet in your phone while we're looking at this for a second. Once you guys are done taking a picture, maybe you can ask your friend. I'm gonna escape this for a second, and I'm gonna, now we'll do some fun stuff. Let me just, I'm just gonna like copy that picture and save it 1 second I'll paste it in Word and I'll save it in this computer. But we'll be using this picture, right? Because it's a nice. There we go. I'm gonna, where does it say? Oh, save as picture. All right, great. So now we'll go to Solidworks and we'll do a sketch as usual, right? Let's do like the top plane. So anybody remembers how to bring a picture to Solidworks? So we go, oh, actually not insert, it's another one.
Tools and then sketch tools.
Yes, but like insert would probably. We go to tools and then sketch tools, which is somewhere around here, and then sketch picture. And I'm gonna go to desktop and I'll bring our picture in here. So voila, now we got our friend the trumpet inside Solid. So this is gonna be super handy because it's a nice picture that shows us like a nice side view. So we'll start tracing some of this for a moment. And as you can see, we can change the overall size. We can leave it as it is, although how big do you guys think this is from here to here? 14? Say 16. Just to make it. Well, I'll write in here 16. All right, so let's actually do the mouthpiece for a second. So let's do that. So I'm gonna start by making a center line that goes like that. And then I'm gonna, so the command that I'll use for this, I'm gonna make a revolve. So I'll just start by tracing all of this for a second. And I should probably be defining all of the things that I'm doing. So that's what I'll do in just a second. This is a part of the class where you can sit down and relax, like as it was a flight, just watching me do a little bit of this. And then I'm gonna maybe try and do a nice spline command. Oh. Yeah, it's a little tricky in there. I'll just leave it like that. Maybe for the purposes of today, even though I know it's not okay, I might not define sketches. So I'm taking myself 5 points off for today's lecture. I think like that looks reasonably well. Let's maybe check. The one thing I might standardize is this so that we know how big the pipe is. So maybe I'll make that 0.2 to make it. Well, that's, how did that happen? Oh. But it doesn't matter because everything seems reasonable in there. All right, let's just leave it like that. So we'll go here to features and we'll do a revolve. No, no way. Well, we'll change it in a second. I don't like Zoom. Oh, sorry for that. You guys couldn't see anything. There we go. Well, I'll just do a revolve along that line. I guess once that that happens, we'll just create a new meeting. I think that should download. So we got, I guess we got something like a valve. But one thing I'll do is there's a command that's called shell. So I'm gonna click in shell and I'll click on that face. Let's show a little preview. So that essentially just keeps like a nice constant, just like thickness across it. So maybe I'll do 0.05. Yeah, that kind of looks like it. I'm just curious on why it didn't do it on the other side. So maybe I'll just click again in there. Let's show a quick preview. I guess we can just do a sketch in here. And I'm gonna do a circle right on the middle. Actually, hold on. So this should hopefully be easy, making the valve. Now we'll do something a little bit more challenging, per se. That should be a lot more fun than this. Let's do it like that. Oh, all right, so that works. And now, do you guys remember how to change material properties? How would you do that? Yes. Yes. And what material should we choose? No, I'll use aluminum for this one, but like rubber could have been an interesting one. Let's just say, yeah, let's do 60. I was about to go for that one. Or 163. Right, so not bad at all. So we got ourselves a nice looking bulb in there. So I guess I'll save this. I'll go to this one. I'll call it no, actually mouthpiece. All right, let's do another part. So now file, file new part. I just went back, and I'm gonna go back to sketch. Let's do a sketch in the top plane. Go here to tools, sketch tools, then sketch picture. We'll bring our picture once again, and then we'll define that as 16. We'll click OK. So now, yes, now I think it's a good idea to start making the central cylinders. So let's go ahead and do that. One way I think I might do this is, so the picture in itself is not entirely sideways. There's like a little tilt to that picture. So one way I'm gonna do it is by making 3 lines that go like this. Oh, yeah, I should probably not define. Give me 1 second. I think one way that we could do this, I think I'm also going to use revolve for this because I think it might be just slightly easier. I'm going to trace a line. So this is also like a very rough. Oh, if you guys have any questions, please definitely ask them. Oh, so let's see whether it allows us to do a quick revolve around. Oh. And I think one idea, so we need 3 of these. So then what I'll do is I'm gonna do a sketch in here, and I'm gonna draw just a straight line. It goes like that. And then what that will allow me to do is I'm gonna exit and I'll go to features and I'll do a linear pattern. And the reason why I wanted to do a straight line is because now I can choose that as my direction in which this is gonna be going. So then I'll say that I wanna pattern this and I want to have 3 of them. And then maybe the distance between them, let's make it, actually, let's see what, let's say 0.7. I think that looks reasonable. Oh. Actually, before I do this, I think there's something else I should probably be doing. Yes. Maybe what I'll do is, because if I were to do that, it would create the cylinders as individual bodies. So then you're gonna be like all floating in space. One way I'm gonna do is I'm just gonna add like 2 pipes that go, if you can see on the design, like these two that go in the middle. So I could go ahead and do that 1 second. Let's see. So I'm gonna do a sketch on maybe where's the right plane? Yeah, I could do it here. So I'm gonna go from that point, maybe like that. Yeah, that's good. I will do a circle in there, a circle in there. Let's give it maybe 0.2. Let's give that 0.2 as well. And maybe let's bring it forwards by, I don't know, 1.8. Maybe more than that. These are like trial and error in here because I'm not sure which are the numbers that would probably work. We'll do that in there. And now, if we were to do I'm just gonna do another sketch. So now I just need to draw a line that is now parallel to those cylinders. That's what I'll do. Second, exit, features, linear pattern. Let's choose that direction. There we go. All right. So that doesn't look too bad for now, right? So maybe let's try and hollow the inside of these cylinders. So for that, I'll just do a good old sketch in the top of these, right? And maybe let's do a line that goes like that just to mark the, I don't know why. Hold on, let me just delete that a second. Line that goes like that. Maybe another line goes like that. Oh, we got less than a minute. I'm playing against time right now. Yeah. Zoom. Probably will give me time to just show you this for a second. Let's bring. Good. So we'll just continue again from this one. Let me just join again. This one in here. Sorry for that. In here, 50, 62, and 75, 79. One second. Oh, that is. All right, there we go. Perfect. Yeah, sorry for that. Now we're back in here. So yes, all I'm gonna do is I'm gonna just extrude cut all of these. And I'm gonna maybe bring them down. I can say something like up to surface. I'll bring them down to there. So then yes, so we got the body. So what can we do from here? If you look at the picture of the trumpet, what could be like a nice follow-up? So like the keys, we can definitely do the keys. But I would actually save them for later once we do the assembly in just a moment. I was thinking maybe we try doing like this part that goes all the way like this. So it leaves like one of the valves and then it goes all the way to the front and then way back. The only problem is that if you guys see the trumpet, if you guys can pass it back in a second, it's like a little bit angled. Do you guys see how if you look at it from here, it's not entirely aligned with the band because the bands are in the middle. So here it's kind of pass it around, and you can see that. So to that end, one thing that we can try doing is the following thing. So I'm gonna go to my friend, the top plane, and I'm gonna do a sketch in here. And there's a, well, why is it? I'm gonna convert entities, 1 second. I just use a command, convert entities, which just literally projects like surfaces into planes. So I'm gonna use that in here for a moment. And yeah. Oh, that is very important. Thank you for that. Why am I not? Oh, there we go. Sorry. Thank you for. So I'm gonna just do a center line that goes like. So I want a plane that is more or less oriented like that line in there. But now I'm trying to figure out how can you make a plane that looks like that. And one way I would do it, right? You want like a plane to be along that line. So maybe a way I would do it is by creating a center line that is perpendicular like that. And now I'm gonna exit. And then I can go to features, then reference geometry, plane, and click on the point and click on that line. So now I got a plane that is just like angled like that. So then when we are doing all of that pattern in there, what I can do is just like trace it along that. So maybe then what we can do is go back to our sketch. This time maybe I'll do a sketch in plane 1. Actually, I don't. Let me go here to tools, sketch picture. And I'm gonna try and bring the picture of the trumpet in there, even though as you can see, it's a little bit angled. So maybe what I'll do is, let's see if I can rotate that by maybe a couple more. Oh. Why is it doing that? Oh, maybe 270. There we go. All right, perfect. I'm gonna leave it like that, and maybe I'm just gonna vaguely move it like that, and I'll make that 16. So this is where the whole process becomes a little more approximate per se. I want to try sketching like that. So this is going to be interesting, and I'm not entirely sure whether it's going to work or not. But we'll see. That's like the why we're here. Just to remind you what I'll do, I'll be doing this one, the one that goes all the way through the side like that. So maybe I'll just start tracing a line that goes like this. And then maybe a small semicircle that comes like that. And then a line, oh, that goes all the way there. So now we're going to do a sweep in here. I'm going to exit the sketch for a moment. Maybe if I go back here, I can hide that picture. So maybe, oh, can I press it? Yes, perfect. So now what we'll do is I'm going to go to features, then reference geometry plane. I'll create a plane on that point right there, as I just did. And then I'll do a sketch that will essentially be the if we can do that 0.4, which was, I believe, the more or less the diameter of the valve itself. And now we can exit and go here to features, sweep, and we'll choose that as our profile. This is kind of beginning to take shape. I wouldn't say it's looking particularly good yet, but we'll see, because now we need to find a way to maybe make this go into here. And I think I have an idea for that, which is we can use a loft for the, would you guys believe me if I said that? Because actually, let's say it goes to the middle one. What? Yeah, yes, it's a little bit tight. One way we can do this is by saying, I'm gonna make a sketch that goes here, like that, and then we're gonna make a line. So as you can see, we're creating a lot of planes. So we go here to features, reference geometry, plane, and I'll make a plane that is just chops that little valve in half. So that's what I'm doing for a second in there. So now what I can do is try and draw something in here. Oh. In that plane, give me 1 second. In fact, I can try, I'm gonna do something that's all convert entities. I'm gonna convert that entity in there. So all it does is bringing that little circle up to that plane. So that would allow us to maybe do like a little, actually, I'm not gonna use loft. I think it might be better to just make it a path to continue the sweep. So that's what I'll do in there. I'll just draw that line. Maybe I'll exit for a moment. And then, oh, actually, I'll go back here. And I apologize that it keeps on moving. I will make that into a construction geometry. There we go. So now I'll exit the sketch. And what I'll do is the following thing. I go here to features, then sweep, and I will sweep that along that path in there. And then there's a command that's called here align with end faces. Well, actually, I don't think it's gonna, I should probably change a little more the curvature of that line. But if I do that, well, at least it kind of brings it there, which is good. So maybe I'm gonna say that's good enough for our purposes. So let's try and finish the more important part of the trumpet. Let's do the bell, and then we'll continue doing some other fun stuff today. So for doing that, I just want to create an exact plane similar to this one, but on the other side. Question? Like a line. Yes. If you we can chat afterwards and you can like draw it here. Yeah, so like one last thing, or maybe you know what I'll do? I'll leave the trumpet in here because it might take me a little of time so I can continue doing the slides. Maybe if we have time, I'll continue doing it. I wasn't expecting it would take more time. In any case, hopefully you kind of get the idea for now. So let's do some announcements. I guess this is where I more or less wanted to break the half of the class today. So Dustin wanted me to tell you this, that apparently there's gonna be donuts tomorrow, 1:15. So definitely be in the lookout for that and take a picture if you're interested. Then another interesting announcement is that today is chocolate cupcake day. So eat a cupcake. Maybe after class I may get a cupcake myself. And this one is definitely one that you guys didn't think about, which is today is actually Alaska Day. And I don't think anybody here from Alaska. Yeah, that's what I thought. Like it's very far away. So now if you see someone from Alaska, you can tell them Happy Alaska Day in there. And then also some reminder of deadlines that we have going on this week. We have, oh, I should probably minimize this for a second. We just have like saddle and fasten going on. So definitely bring your fasten to class when you come. And then the last thing we have is this, which is the CSWA. And I don't know whether I'll have time today to go over this. So this will be probably covered in recitation, like how to actually make this part. But that doesn't matter. So do something a little more fun, which is the part of the class where I tell you all of the different things that you can do with SolidWorks without actually designing. And I like enough Dr. Zeus, so that's why I have like all the places you go in here. So there, have you guys heard of finite element analysis before? Well, hopefully we'll talk about that in a moment. Then these are different softwares besides SolidWorks that we might look in a moment. We got also topology optimization, which is another interesting thing that we can do, and rendering. So let's get started with like, well, I think some of you guys have seen me do renders in recitation. If not, I guess I'll introduce the idea now. Essentially, renders is when you take like an airplane like that one, which is hopefully would have been the trumpet if it hadn't taken like that much time. And then you can make it look a lot prettier by changing the material properties and whatnot. And we'll do a quick demo in just a second of how you can do that. Then there's something that's called FEA. And FEA is essentially when you give me a part that looks more or less like that, and you're telling me I want to simulate a set of forces that are acting on that part, and I want to see whether it's able to sustain all of that force. So then you can go into SolidWorks, and I'll also do a demo in a moment, and you can establish like boundary conditions, saying that you're fixing those 4 points and you're applying a force that goes there. And then SolidWorks will actually spit to you results that I think are pretty nice to see. For instance, you can look at the stress. Let me just move. Hold on. I'm gonna move that away from here. You can look at the stresses, for instance, and you can also look at the displacement field, which is what we have in here. And I'm not sure whether anybody has seen this part before. Nobody has seen it. Have you seen it? No? Yeah? Where have you seen it? Oh, yesterday, like yesterday evening. No, this part, there was a challenge a couple of years ago where this is an engine bracket of an airplane. I believe it's done by General Electric. There was a challenge to say whether you could optimize that shape a little bit better. And yeah, so here's just a quick description. And yet, still related to that is something called topology optimization, in which case you give me a part that kind of looks like the previous one. It just has much less details. It has like quite a lot of mass. And you're applying the same boundary conditions. And you're asking SolidWorks to see whether you can still satisfy those boundary conditions, but begin to remove material that is unnecessary. So I think this is like a pretty cool application of like how just like geometric optimization works in mechanical, because in a field like aviation, right, you want to minimize weight. So you're looking at parts that can still satisfy your constraints. And in this case, you can define 3 different constraints that you can ask SolidWorks to work for, while also just like minimizing the mass. So I chose for that simulation to maximize the stiffness to weight ratio. And here some real world applications are, I show these 2 papers in here that hopefully the slides will be available to you guys and you can maybe take a look. So those are like the real challenges that were done. And with additive manufacturing and just being able to 3D print using metal, I think this one is particularly promising because that geometry definitely cannot quite be machined. There are machines, you cannot quite have like an ending, right, trying to remove all the material in there, let alone that one. But you could definitely 3D print it or cast it and still satisfy the same boundary conditions. So let's do a quick demo on how to do all of this. So I'll go back to my email, 1 second. Let's see. Oh, this one is from yesterday. Give me 1 moment. There we go. You can see I have a lot of emails. So I'm gonna choose. Let's do this one. Perfectly. All right. So the way that you would do it is if you go to SolidWorks, it already has a tab that's called simulation up there. So we can click and then go to new study and then just go ahead and say, okay, because we want to do a study that is static. So it's going to ask us to establish all of these things. I should say that before, if we go here to say that was a material, I did change the material before. So this is aluminum like we did a little bit earlier. But now we can go to where it says fixtures and I'll say it's a fixed geometry. So I am going to select maybe all of those points that you can see here. And I'll say, okay. And then it's asking us for external loads. So I'll say I want to apply a pressure. So for the pressure, I'll choose maybe that surface in here, but then you can specify a direction. So the direction I'll specify is just along that edge. So you can see the arrows are pointing downwards. Now maybe let's say something like 100 newtons, and I click OK. So then we can go to where it says mesh. We can right click and go to, I like just mesh and running. Just if you are patient and you let it wait for like a minute or two. That was quick. I mean, there, so you can see it. So it's spitting out like the results. And this is quite nice because it's super realistic. I will say Solidworks is not a software to do simulations, but it still has this functionality if you want to do some rough estimates. And as you can see, it doesn't even reach the yield strength of aluminum. In this case, is that value, 10 to the 8. And these stresses that you can see are not even close. So this part won't fail at all, which is great, as you can see here. And then if you go down there, you can click on the displacement field. And you can see more or less with the colors, how much every part deformed. So this is, of course, amplified the deformation. I think there's any questions about this? No, good. And then like to do the topology one, I don't think I'll do it now because it might take, well, actually I could do it now. Maybe it might not take a whole lot of time. I'll just click here and I'll do, if you go back to simulations, I'll click on new study. But instead of clicking on static, I will click on topology study where it says there and I'll go okay. And then the same things, I'll go here to fixtures and I'll say fixed geometry. So maybe let's choose again those 4 areas in here. So this is a version of this piece, but just like with a lot more material on it. So it's a very rough estimate. And then we can go to where it says external loads. Let's apply a pressure again, right there. Let's say it's 100, and let's define that direction. Let's say okay. And I'm gonna ask us for the goals and constraints. So that's where I click maybe best stiffness to weight, and I want to reduce the mass by, let's say 80%. And now we can go to mesh and say mesh and run. So let's see what it does. I'm not sure how quick it's gonna be or not. No, actually, this one might take a little bit longer. So you guys can question. This, so it was supposed to be like a little bracket that when you have the wing is supporting the actual engine weight. I think probably the engine to this in here. It's great. It's quite cool, and that's why it was mostly led by General Electric. I thought it was a good thing. Let's see how long this. Let's give it like a minute until it loads. I think it's like a cool thing that you guys can do because I've used this when I was taking MEAM 347. Like later on in the MEAM career, it's not something that you really get taught nor encouraged to do. But if you're trying to optimize your shapes, right, and still be able to like satisfy constraints, I think it's a perfect like tool that you can use to achieve that. Might take a while, and I'm a very anxious person, but we still have a couple more things to do besides this. So maybe if it doesn't stop by minute 2, then I'll just continue doing something else. But you can see this one takes a while because you're essentially simulating the piece, removing material, simulating again, removing material, simulating, removing. That's why it's calling it like different iterations. And with each iteration, you're trying to see whether by removing material at special area, if it's satisfying the constraints that you imposed at the beginning. I'm not sure. I do have I did a topology study yesterday evening, which is how I took those pictures that I included in the slide, but I'm not sure whether they will be saved or not. Let's see if I click here. Oh, right. Is this one still running? Well, I can leave it running in the background and continue a little bit more with the slides. We'll come back to that in just a second. So it's like a cool thing. So we'll go back there. But now another thing I wanted to talk about is that there's not just SolidWorks that you guys can use. There's also lots of other software. And so one that I really like is Fusion. And I'll give you a quick comparison of the different types just in a table in the next slide. This one is actually free for students. So, and it's super simple to use. It's a little bit easier than SolidWorks per se. So definitely, if you guys have a chance, maybe I'll do it in my recitation at some point. This one is the one I started with doing design work back in the day, SketchUp, because I like architecture a lot, so that's where I began. Then there's Inventor, which is part of Autodesk, and also AutoCAD. I thought that was it's like a nice one I've used over the summer. And here's just like a quick comparison of the different ones that I've found. And I'd say definitely just take a look at the numbers. This is more or less my impression of how hard I think of them or how similar they are to SolidWorks. And all of them besides SolidWorks and right now are free for students. So you can download them at your own convenience. And those are some of like the cool features that I think just make them stand out from other software. For instance, I think of Inventor and SolidWorks are very similar to them. Although SolidWorks has something called design tables that we'll be doing later on in the semester. Then Fusion has something that's called generative design, which is similar to topology optimization. And then just architecture stuff in general. And these are some of the things I've designed. For instance, this is in Fusion 360. And that's a Chinese instrument, a string violin that I have back home. If you click on the links, it will take you to something that's called the 3D gallery, where those designs are up online. And these ones are in SketchUp. In my free time, I like designing airports. It's a completely different domain. And so you can click in there and it will take you to where you need to be. But I think SolidWorks is still. Oh.
Why do you like designing airports?
I think they're fun in general. Because it's a long story, but when I was younger, I used to collect model airplanes, but they're very expensive. So if you design them, you don't need to pay for them. So I can play virtually in that world. But in my heart, SolidWorks is still the nicest software of them all. And this is, for instance, one of the things I've done last semester in a class called IPD 501. And this is also another project, and I'll be opening them in just a second. So that's our final project. We did a train. The train is currently in Los Angeles, unfortunately. We have a chessboard. That's my 201 engine in there that you might see it in the shop if you're around there. I just donated it to Penn. I don't care. And this is also, I did it for fun. I like, as I told you, riding bicycles. So I designed my own in there. So let's see. Oh, before I look into the CSWA exam, and I have a little surprise regarding to that. Let me see if I can download my friend the train. One sec. Oh. Hold on. Wait 1 second. So I can show you how a big assembly looks like. Well, actually, I think the results are done for this. 1 second. There we go. This is like the topology results that we just left running in the background. It looks like a little giraffe when you look at it like that. It's just satisfying the constraint. It's also like yellow. So it's telling you, yes, you can just follow the color scheme to more or less guide your options from here. But let's see if I can download or go back here. Oh, there it is. I don't know why it's not letting me download the. But that's I'll come back to this in just a second, but I'll continue with the slides. But now, more importantly, what Dustin really wanted me to talk about today, which I got only at the very end, is about this, which is the fact that with just taking 101, you can actually take the SolidWorks branded exams. And one way I like to think about them is in the way I do it there in the top. That if you do take the SolidWorks exam, it's like somehow, and I use like this symbol that is called homologic. It's just like it's an isomorphism in math, which is like equivalent per se. To like when you go here to the States and you do like the TOEFL exam, for those ones that are international, which is an English certification, or you do the HSK, which is also a Chinese language. So if you do this, it's like obtaining a SolidWorks official just certificate that says that you can actually do design work. And more or less the way I broke it up is that there's 3 exams, and more or less the topics that fall into each one of them are listed in the bullet point. And you see that at the end of the semester, you will definitely know how to do all of this. But there's a couple of things in this one, like equations, operator, design table, math property. Like most of the stuff you also know how to do. And in that one, I would say that probably you will sketch pictures for sure, sweeps for sure, then maybe important parts. So that one's a little bit more advanced. And actually, question. Yes, that's the one in which I did the train.
That's like you don't take that like.
No.
Okay.
No, but you would need the order in which the classes happen is 101, then this one, 201, and then you can take 501. But it's a great class if you have the time. It's just, even though it's just 1 credit, it's like taking 3. Given how intensive it is. You essentially live in the shop. But yes, we can talk more about that in just a second. But so you have these things, and I've done this one last semester, and it's super easy to do. And it just so happens that I have a guest today in the class that has passed the expert exam, which is awesome there. Do you want to say a thing or two about how you found the exam?
So basically, I work in Israel in a company that gives service to other companies in Solidworks, and it's part of the job. We need to do like a lot of exams like that. There is much more than this. So
there's like 16 of them. I think.
Yeah. So actually, for doing the expert exam, you need to first doing surfacing, sheet metal, weldment, drawings. Yeah.
Was it hard, the exam?
Yeah.
It was hard. You know, from someone that literally does this as a career. But yes, I'll never encourage you. I hope someday to do the professional one, maybe next year, maybe with you guys at the end of the year, and someday the expert. If you can do the expert, you're an expert in the topic. So definitely go ahead and do that. And now, I do not really think we'll have a lot of time remaining now, because I also want to give 10. Yes, literally, we're limited by that. Just closing here. But what we'll do this week in lecture, I should use this mouse here, there we go, is that we are going to be designing this part. And this is one of the practice parts that you can use to make to practice for SolidWorks, the associate exam, which is the first level one. So maybe it looks a little bit intimidating, the drawing, but it's actually not so hard at all. So here's a quick summary of the things I hope that you've learned so far in the semester. Is that there's a lot of different commands that one can use in here that we've covered. So it's a matter of trying to look at the design and seeing whether you can implement those, what is most convenient given the situation. Then there's, of course, a little bit more than just designing. There's like the fact that you can create, I haven't shown you how to do renders, I'll do that in a second. And then you can do FEA or topology optimization. And then SolidWorks is always in my heart, but there's other things that you can do. And yeah, the possibilities are endless. But before I continue with the very last slide, let me just show you one last thing that might be useful is that, let me maybe I can actually use the valve as an example. I'll change the material of this one again to aluminum. So if you want to do renders, you can go to where it's to where it says SolidWorks add-ins, and there's a tool in here that says Photo View 360. So we'll click in that 1 second, and you wait a second, and this little tab appears. So we can go to where it says Render Tools. And one thing I like first clicking on is on Options, and then going to where it says here, I'll make it like best quality, right? And then if I right click, I can edit the scene. So I can maybe make that blue. I can remove the shadows per se and just leave it like that. And then we can do a preview window. And if you give it a second or two, like a nice window will appear in here. And it's gonna start rendering your view in there. And I'll just say, I wanna render it in the fullest, the whole quality. And then it looks like quite legit in there, the valve. So maybe I'll try and finish the trumpet later, and I'll show you a render picture of how that look like. And you can wait until it's rendered fully. Right now it says like 96%, and then you can just save the preview picture, and that's it. That's how you can very easily render just like pictures in SolidWorks. Yeah, that's good. But I'm gonna leave that. Let's go back to the slides 1 second. But we're still not quite done. Question.
Do you know what day the exam SolidWorks exam is?
No, but I can definitely get back to you on that point for sure. And then yes, just some concluding thoughts, like even beyond like SolidWorks, is that here at Penn you can do all sorts of things, not just design work. And this guy in here is Professor Bargatin, which is the undergrad chair. And I wanted him to come today, but he couldn't. He was busy. And I work with him. I've been working with him for 3 years. So definitely, if you're interested in research, I'd love to chat, because that's one of the coolest things you can do here at Penn. And one of the things I did last summer with him is just making things fly using sunlight. And it's just like stop it there. And those are videos I recorded last summer. Oh, sorry for that. You can see how the little plate in there, it's levitating about 1 centimeter from that mesh from which it's like rising. And that's all sunlight. We hope someday to be able to put like micro satellites on them and be able to scan properties about the atmosphere. You know, if you're interested in anything related to this, I'd love to chat. I think he's an outstanding professor. Yeah, so definitely explore opportunities here at Penn. As you want to have fun, right? Take this class. Don't stress too much. I would say challenge yourself, right? Because you're here to learn a lot more. So step out of your comfort zone. One that is not a small one. Try to smile whenever you can, because I think smiling is good. And one that I'm going to do right now, which is my favorite one of them all, is to take many pictures. So I'm going to take a picture of you guys right here. And I like taking selfies with my students. That's what I do right there. Can you take us? Okay. What is that? Right. Come. But I do have. Oh, I'll say it for later. Right?
I will.
It's like a soccer squad. You guys can see.
I should not do that. I'm not tall.
Oh.
I don't squad.
You don't get asked to take pictures, so I'm sure. This all goes to Winston, I don't know why. But you guys should come.
3, 2, 1, say Andy.
Andy.
Now point to the best way ever. Yes. Amazing.
Very nice. But I'll say here because I do have a little gift for you guys, which is these little Lego guys. So let me get you. Yeah, they are of course. I literally packed them all. I packed them in the Definitely feel free to say one. You know, I like to give you some these ones.
Yeah, it doesn't.
No, it's very quick. There you go. Yes. I can use them as like keychains.
Oh,
I thought you were going to be giving us
That's
the
not
stuff that
right.
we have to like take it.
But it's not done because I did promise that I will give you a little text or that's what I do.